Okay. All right, I can see myself on the screen. 2 seconds behind me. All right. Hello, everyone who's listening. I'm not going to have much feedback, but I can see the chat if anyone has questions. This is the. Oh, sorry. Sorry, I just had audio from different computers competing. All right. Yeah, there's about a 20-second delay that I can see. All right, so this is the intro to the CTF. CTF is put on by CyberUC and Northrop Grumman. I work at Northrop Grumman, and I'm currently the president of CyberUC. They're both excellent things to get involved with. So if you're looking for a co-op, Northrop Grumman's a great place to work. If you're looking for something to do in between classes, CyberUC is a very fun club to be a part of. Sorry, got some cats that are misbehaving. The CTF is up at ctf.cyberuc.org. So if anyone hasn't found that link yet, I think we've put it up quite a few times, so it should be easy to find. I'm just going to go through the process of getting logged in here for anyone who's new. So when you first go to the CTF page, this is a scoreboard. You just have to register. You just put in the name. Keywords loud. I'll use my other email. You can use any email you want in here, but your UC email is preferred. I've just already used mine. Okay. So when you first get signed in here, you'll need to either join or create a team. Teams should be capped out at 4 people. I don't think that's mentioned anywhere, so my bad. And also the prize for the CTF this year is going to be a single $100 gift card for Amazon provided by Northrop Grumman. So if you have a team with multiple people, you need to figure out how to share between you all. So I'll just go ahead and create a team. So Chris, I'll tell you my password so no one joins this. And then you're in. So that's the registration for getting on the site. There's a few people who struggle with that every year, so just want to walk you all through that. So first question, what is a CTF? The CTF is a kind of a competition for doing computer science related challenges. There are hardware CTFs that are beyond my knowledge, but mainly they involve a combination of cybersecurity skills. So we have reverse engineering and binary citation as our kind of main challenge set here. And then we have a few other cryptography, stenography, and web programming problems, not web programming, but web exploitation problems. And a few other that are opponent tools is a specific tool for Python that you can get comfortable with if you like. You can use any other tool you want for that problem though. So for connecting to a problem, you go to the description. You see on here at the bottom of every problem, every problem you need to connect to get to a flag. You see nccyberuc.org and that port number. That is a command for Linux platforms. You could also use telnet, I believe. I've tested that recently. .org. 48672, and then you'll be connected to your problem. If you read through the binaries that you can download, you can reverse engineer them to find exploits. So that's nicely. It doesn't quite work that time though. So that's kind of the basics of navigating our CTF. Other problems on here are just problems and you don't have anything you need to connect to, or they have files that you need to download but nothing to connect to. So one of the main problem categories on here obviously is reverse engineering. Is our second largest category. And we're just going to dive into a tool called Ghidra, which is a reverse engineering tool published by the NSA for doing software reverse engineering. Oh, yes. Sorry about not posting the link in the chat. So to get set up with Ghidra, you need to download it. It's a Java program, so no matter what operating system you have, as long as you have JDK 11 or equivalent, this should work. And if you don't have JDK installed, they have an installation guide down here. Unfortunately, Oracle's main Java site, you have to now create an account and download JDK that way, or there's adoptopenjdk.net. I'll throw this in the other YouTube chat. It's not the mouse. Tab over to it eventually. One more. Okay. .net. So that's a site where you can get a not Oracle's JDK, but OpenJDK, so a different distribution of Java development kit without having to create an account or anything. OpenJDK 11 is the current LTS, which is long-term support, so that's what Ghidra is currently using. Hotspot as the JVM is fine. You can use either one. There's not really a discernible difference from Ghidra's perspective. And then other platforms. Yeah, if you click other platforms, you'll be able to go down to Windows if you're on Windows. I am not on Windows, so I'm not going to be installing this. I've already got them set up. If anyone has questions, what Linux distro do I recommend? I use Ubuntu with KDE Desktop, Ubuntu 18. I've recently become less interested in Ubuntu as they've kind of forced their package manager onto their users. So that's just my personal opinion. I will fetch if anyone's curious in my details of what I'm doing. You can just pause on that frame if you want. Yeah. As for recommended for this challenge, what do you need to download? You need the OpenJDK 11. So just any of these for whatever platform you have. And then you also need, go back to Ghidra. Oh, I'm sorry. I didn't put the link for Ghidra in here. Let me put that in the chat. Ghidra.org. Yeah, so you need both Ghidra and AJDK 11 install. So when you, let me do this in File Explorer actually. So it's easier to follow. So when you download, it's very large. When you download Ghidra, you need to extract it. It's just an AZIP file. Yeah. Then inside you'll have Ghidra, their version numbers, and some additional documentation. Inside Ghidra, the folder with the version number, there's two files you can use to run Ghidra. Ghidra run.bat is the Windows runner. It's a batch file. Ghidra run.sh is the Linux runner, so it's a shell script. So I'm on Linux, so I'll just click that one. The first time you run this, you might need to run it inside of CMD or PowerShell or Bash. So let's make that larger. I did not make it larger. So you might need to do like Ghidra run.sh or Ghidra run.bat from your command line, whichever is appropriate for your operating system. And if you don't have Java installed correctly, I know there's a lot of weird path stuff with Java. You might have to tell Ghidra manually where to look for Java. So I'll wait 1 minute to see if anyone has any questions in the chat before I continue. Yeah. I think we're doing good. If anyone is, I imagine the download for this is not fast right now. So if anyone needs help, feel free to reach out to me on Slack, either now or after this. Although I guess the YouTube chat is probably best for right now. So when you finally get Ghidra open, it'll be this kind of window, except you'll need to create a project first. So Ghidra doesn't operate on individual files. It operates on projects with files in them, kind of like an IDE project. So you can just create a new project, whatever you want. See, I'll just one more line. Finish this, and That's your new empty project. So I'm not going to do any of the problems on the CCF right now, just because they're for points and there's an actual prize this time. Instead, I'm going to download a problem from Patel, which I know is really easy. I know, because I work for. So they have a very easy CTF problem on their website called Feed the Magical Goat. So I'll put the link for this over in the other chat. So I'm just using this challenge because I'm super familiar with it already. It's very easy. So if you read through it, there's a list of inputs. It tells you which categories are all in. You have to figure out how to feed the goat, which is just the binary using the listed items, and you only have one of each. So just to not read this right now and kind of jump through it, is we have 4 categories, 4 inputs each, and we need to give each one of them to this binary in some format to get a executable or a flag out of it. So CTF2, I already have the CTF. And then you can just unzip that with whatever you want. You can do it in Explorer and just use unzip. Yeah, pretty easy. So, first thing we want to do whenever we have a CTF problem is to figure out what we're looking at. So what we have here is a ELF 32-bit executable, which is Intel 803086, which basically just means a x86 binary for Linux using libc somewhere here. And it's not stripped, so we have a few symbols in there, probably function names, things like that. And we have to use a file, which we already saw. So I'm not going to, I guess we can run this real quick. So if we run this real quick, we ring the chow bell, summon the billy goat. So billy goat looks around, anger fills his eyes. You should cover your webcam, but unfortunately I'm streaming right now, so that's not really practical. So if we also look in our directory after we run it, you won't be able to run this on Windows, by the way, because it's a Alpha executable. I guess you could use the Windows subsystem for Linux, but might have some difficulties there. So we can see the file also deleted itself after running. So we'll need to keep a lookout for that while we're trying to figure out what the flag is. So let's jump back over to Ghidra. And I'm sorry if Ghidra's text looks a little bit small. There's no way to increase the size on it currently, at least not in my version. So I have a older one. Version 9 flat. All right, so I kind of clicked through that really fast. To load a file into Ghidra, you do File, Import, or you can just hit I. So if you look in here, there's a like the actual action and then the macro next to it. Ghidra likes to have a lot of macros, so you hit I, opens your file explorer, you go to wherever billy goat is. You can just double click it, import it. Ghidra knows it's an ELF file, which is a Linux executable format. Language is x86 32, so Intel 32-bit. Program name billy goat is fine. Destination folder is the project folder it's going to move it to do analysis on. So it's actually going to copy this somewhere else before we take it apart and look at it. So here's some more metadata that it can tell from the program. So the program's name is billy goat. We last modified it today, 2 minutes ago, not even 2 minutes ago, 2 seconds ago, when we unzipped it. It's not read-only. I guess we can run it, we can write to it. Processor information, so like I said, ELF 32-bit Intel. Some ELF header information. There are 56 functions in this, but there's not really that many. A lot of those are imported from other libraries like libc. Required library, libc, so just a standard C application for Linux. And then we can see the names of the source files that were compiled with it. This is because this binary doesn't have symbols stripped out of it. So it's just some extra debug information. And it's not relocatable, which is a thing you can do with assembly code to make it so you can move it around in memory relative to itself. Or not to itself, to wherever it loads. So double click on Billy Goat inside of our CTF project here. I haven't seen any people reach out for help on getting Ghidra set up, but I'm happy to help later because we're kind of past it now. So first time we open our binary, it'll say Billy Goat has not been analyzed. So we're going to go ahead and analyze it. The default settings are fine on here. The ones in red won't take that long on this file because it's really small. I'm not going to go through all of these. It's just plenty of documentation in Ghidra's source code on what these do. So hit analyze. So progress bar down here in the bottom right, it just kind of turns away for a few seconds and then it's done. So it's decompiled, analyzed. So on the left side here, you make this larger a little bit, not that large. We have our functions list, our exports list, our imports list. So imports, we can see we have libc is giving us some functions. I guess it didn't show us which ones were. That's where they come in a different section. So these are all the libc functions. So libc start main is how like C programs are loaded from assembly via libc. Exports, so these are the functions we create inside of our program. That'd be on Windows, equivalent would be like calling a DLL function. In Linux, you can just kind of reach in and call them. So let's just go straight into our main here. You see on the left side under our functions, we have one literally called main. That's because it's not stripped and it is a C program, so we see the function name still. We can also do navigation go to, so G, and then we can type in any function name or address or label in the program. So main will take us right here again. So if we navigate away, if we have a function that we know the name of that we want to get to, we can come back to this, type in main, go, and just do it. So we saw this problem. It's a binary that we can run. It has some list of inputs on the website that we want to give to it to get a flag out. And we have it disassembled. So let's kind of dive into it here. On the left side, this is called a control flow graph. So this is the assembly logic blocks. So this is the beginning of main, an if statement, an if statement, an if statement, and then a middle if statement. And then they all have the same if fail, I guess, or if not. So they all end in the same execution path, which is down here. Oh, that doesn't look right. So is that string call? So we can see from our main, we have four if statements that we need to satisfy to get to this code block. And then we have something down here that we can, there's a large mess on my screen now. Not sure how to get rid of that, so let me save this and reload it. Yeah, so Ghidra has a few small UI quirks like that, where if you hover over something for not long enough for it to load, it'll sometimes glitch out on you. All right, so we're at the top of our main here. We haven't really done anything yet. As any computer science student should know, the first parameter to a C function's name is arg C, so arg count. We can go up here, select our argument, and either right-click and rename, or we can just hit L. There's also retype if you want to change the variable type, although I don't recommend that because it'll mess with Ghidra's memory analysis. And then we have argv for argument vector, is a char source, so a list of strings, or pointer to a list of strings, string array, and a list. And then we have some variables inside of our main function here. So Ghidra sees these all as defined immediately. So if you were to define a function down here in like the middle of the C function, when you compile that, it's effectively going to be as if you'd have declared it up here because of how C allocates memory, unless you do it inside of a for or inside of a block, but it's different. So let's just kind of see if there's anything easy we can pick out of here. We'll go over to the right side. So I didn't explain what this is. This is the same view as what we're seeing in our control flow graph. And you can see I can highlight things on one screen and they'll show up on the other. So Ghidra is very nice. You can pop out on these windows and have huge multi-monitor setups. Kind of look at a bunch of stuff at once. So we can see in our control flow graph, we have if. That's what all these splits are. So we see a few strings. You ring the chow bell. Oh no, here comes the billy goat. We already saw those when we ran the binary earlier. There's some sleep functions in between those because it was waiting. It's a print intro function. It's kind of hard to see on the YouTube stream, so it's there, I promise. We also see a function called give offering that takes a static string called chow.down. So that'll be important later. Then we see the if statements we saw earlier. And then in the middle of all those if statements, it says Billy Goat looks pleased. So that's probably where we want to get our flag. And then we even look below that and we see printf flag and then a large formatted string. So unfortunately, this doesn't have our flag in plain text that we can just extract out of here using strings. So another thing about binaries is in Ghidra, we can run strings, or we can see all the strings in our binary by going to Window, Define Strings. And this will show us everything. So here's some of the stuff we've seen already. Here's some C program information, some ELF stuff, more ELF stuff. I guess that's libc. Here's more of our application strings. So in here, we see our flag %C%C, so our big printf format string for the actual flag. So we'll want to see how to get to that. Some fake goat facts. And a hint. So that's what we're going to now. If we feed the billy goat a single can, which is an @ symbol based on the table we saw earlier, we can get a hint. So this is really a hint about a hint, which is kind of clever. And there's a string called totally not a hint printer, but that might be a function. So things of interest already. So let's dive into that. So we have our give offering function, and it seems to be the only input into our program. So let's just dive into that. So our param1 to this function is always going to be chow.down, the literal string, tag string. So we can just rename that with confidence. And see Billy Goat looks around, anger fills his eyes, and that is based on a C open file chow.down in read mode. And if our file doesn't exist, which is if it returns -1 from the open function, basically just delete the program. So unlink sysargv0, which is formatted to binary, or yeah, formatted to the name in Ghidra for nicety. So the program will delete itself if it sees we didn't give it anything to eat. And if we gave it a file called chow.down, here's the if. It'll read it. Creates a 12. No, 17. No, wrong. This many. Ghidra will tell us. Decimal 17 size buffer of characters to read into. So I guess that's statically sized and it reads. However, it's bounded. So I was looking there for a buffer overflow, but it's not going to work as it has a size limit on it. So we can see we're going to read 16 characters in, which makes sense as we have the 4 groups, the 4 characters each. And if our buffer is equal to a single @ symbol, then we're going to go through this print. we're going to call totally not a hint printer, which is inside this if statement. And if it's less than 16, which is x10, we're going to call a function called vomit chow.down on chow.down, and then we're going to delete the binary too. So we jump into vomit by double clicking it. We can see that this also just prints out a bunch of stuff and then deletes the file. I don't quite remember what all this inside of here does. Probably just mangle some strings. Okay, so back up to our delete their window. Not too far. Not far enough. All right, give offering. So we need to give the program 16 bytes from our table total and figure out which order it needs them in to get to the end. So let's try our hint printer first. So we saw already that the program is reading a file called chow.down, opening the file, reading all of its contents, or 16 bytes of its contents. And give it a single @ symbol, then we'll get it. So it's not really point copying this somewhere because we already have the zip file there. So I just created a file, chow.down, got it. It just contains a single @ symbol. So we'll run that. So earlier this deleted itself. We can expect it to give us a hint. Okay, so here's our hint. Goats have multiple stomachs. It's important information. Magical lily goats are no exception. The rumen processes organic matter, reticulum, inorganic, omosum, magical, obomosum, infinite energy. So these actually all correlate to the inputs we had on this site. So inorganic, magical, organic, sources of infinite energy. So these are the characters we need to input for each of these categories. And then if we go back to Ghidra, this one. If we go back to our functions in our program, we actually have, so if we go back to main, we actually have these functions that correlate to the names of those stomachs. So we know that our input strings are going to correlate to these functions, our input characters. So just going to rename some variables now that we got some stuff back from chow.down. So this is our chow.down data. And then it's going to chunk these into undefined 4-bit or 4-byte sizes. So the other CTF shouldn't require any other software. So you can solve any of them however you want. This is just a way to go about these. I'm not sure if that was an answer to a question, Brandon, but just showing off Ghidra. All right, we're there. So we chunk these into like 0. Here first 4 characters because it's a 4-byte pointer. One, file 2. These are just our input chunks in sets of 4. So we can see that our fill rumen comes first, and based on our hint printer, rumen processes organic matter, so we know based on the site that we'll need to give it the organic. Yeah, we'll need to give it this organic section of inputs first, probably. So go back to Ghidra. Sorry for clicking around super fast. If we double click on fill rumen, we can see inside of it we do have these if statements that also tile similar to our main, which is 4 nested if statements. And we can see the characters that are actually being compared in here. So Ghidra kind of trivialized this problem when it came out because this used to be all in just hex view. I remember solving it in that way. Let me see if I can find her. Yeah, disassembly. So this is what this all used to look like. I guess it used to look like what's over here. If you're using something like Radari 2 or IDA Pro or IDA 3, if you're like me and don't want to pay for IDA Pro. So you can go through here, and this is what's actually running on the processor in assembly. The control flow graph is rendered in the actual assembly instructions. I didn't mention that earlier. All right, so let's get back over here. So we have our input, which is the first 4 of data down, which is a terrible name, I know. So if the first character in that is a comma and then semicolon period U, then we get to the middle of this, or in that order, then we get to the middle of this, and then it mutates our input to do something, and then it returns that. And we have a return value in here, so no, not what I want to do. Return value, and then it mutates our input, so strings and C are mutable because they're pointers to strings are. I guess strings are too. So we mutate that. We can assume, based on the fact that we saw those print. Actually, not that thing. So in main we have these print statements, printf, and then it goes through our. Yeah, this is printing out our mutated input. So the flag is actually not in the binary. It's based on what input you give it, and then it turns that back into the flag and then prints it. That makes sense. All right. Okay, let's go to our file. Yeah. So I'm going to split screen this with Ghidra and Vim, and we're going to rewrite a new shout out down that has all of our. What do you mean? Has all of our characters in order that we want inside of it. So comma, semicolon. Sorry if this is really hard to see over here. This is coming from the function fill Grumman. If you're following along in Ghidra, we have comma, semicolon, dot u for our first function. Go back to main. Jump into our second function here, reticulum. So because these are just cascading if statements, we can assume that they're all going to be, or we know that they're all going to be the same as if we just run next to each other. E at h underscore. I'm hiding in here. That's wrong. We have pipe, lowercase p, and capital W. Main. And we have our final function in here. Oh, I jumped out of it. Which is, okay, so the first one on here is if our first integer binary ANDed, I think. Yeah, my C is a little bit rusty right now. Against this value equals text free 8, which is not a printable character, then continue. So we could do the math on that, or we could just do process of elimination from our inputs. So if we go back to our site that has the inputs on it, we have BCRH for our list of inputs. And then CH is missing from this list, so we'll just throw a capital H in there. Or we could additionally do X48 binary ANDed against this value. I think this value is actually wrong on here, though. I think we just want the XU. Or wait, what? Oh, it's not XU. It's unsigned. Or 7F. So that's what that is. So our new lines. Shout it down. Shout out. Is it Billy Goat who deleted itself? And we'll shout down to 2, just to save in case we need to change something. We'll run Billy Goat again. Oh no, here comes the Billy Goat. Goats have microscopic hooks on their hooves. All right. That's probably not true, but maybe it does. It is true. So we got our flag from that. This one's actually not in the CTF this year because we have sold it before. But yeah, if you want to apply it to Northrop, give them this problem instead of Patel. So that's a simple walkthrough of the CTF problem in Ghidra. This kind of problem is something I would call a flag printer. It just mutates the flag and then runs it. So if anyone has questions in the chat, I'm ready to answer them. I'll wait 2 minutes and then we'll run this a far easier way. Jump back to Slack real quick and see if anyone has questions there. Yeah, I'm checking the track Northrop Grumman and the sponsor Northrop Grumman channels real quick. And I don't see anything in the YouTube chat either, so I guess we'll try this a different way now. So if we were, wrong keyboard, wrong computer. If we remember from earlier, we saw a run Billy Goat. It told us that Billy Goat's eyes filled with anger. So anger is actually another tool that you can use to do CDFs. It's for symbolic analysis, which is kind of its own field of debugging, I guess. It's a very strange thing to explain. But if we want to use anger to solve this problem, it's very easy. Just use Docker. If you're not familiar with this, don't worry. But anger is worth researching if you have any interest in what this is. So to mount PPE / data do CTF anger. So I'm just going to run this tool called anger. I did not attach to it. So I'm just running a container that has this tool called anger preloaded into it. So anger is a symbolic analysis tool that's created by the Shellfish CTF team, which is a huge CTF team that actually makes millions of dollars playing CTF. So yeah, so symbolic analysis. Okay, let's put this over here. Symbolic analysis allows us to analyze running a program. So it allows us to all states simultaneously. So if you did intro to computer science and you remember going through execution or for loop tables and writing down what every state was, it's that, but then it's also if you ran every single if statement, every time it branched, if you followed both of those forever until the program stopped. So anything with a loop is going to be quite a monster, but this is just a simple program, so I'm not going to have any issues here. So anger also has a project context, but that's more of a individual binary that runs. Yeah, so we can projects. So creates an anger project, which is more like a execution environment for a binary or symbolic analysis execution. That's weird. It's hard to explain. People who make this are very smart. But we can load Billy Goat into this. A sim manager, which is a structure, it's a class in Anger to run all of our simulations, as I described earlier. Anger does a lot more, but this is just very just run all of the states. So as if we ran this from the command line, it will take every read that the binary makes and do some interesting set math. So if you think about binary running, everything that influences how it runs inside of it, so how we go through the control flow graph with all the if statements, that's more or less just a This is taking a while to run. This is usually pretty fast. Oh, it has a file that it reads. It's going to break. I should have thought this through. But, what was I saying? But every time we go through a control flow graph, every time we go through an if statement, we're really running a constraint on some form of input to the binary. So even like a random number, the input is the seed to the pseudorandom generator for your language. This is not about run correctly. I should have done this better. No. Okay. So it's a terrible intro to anger, but close. But if you're interested in a more interactive program for approaching CTF problems and destroying your CPU, as you might be able to hear my fan on my laptop, anger is another good tool to explore in addition to Ghidra. That's what I was trying to get at there. So, yeah. All right. I think I'm ready to end the stream, but I don't know how. So I hope everyone found this interesting, at least. Feel free to message me on Slack. So for any questions that aren't just what are the answers to this. So thank you for listening, and please talk to the Northrop Grumman people while they're here.